Welcome to The Explainer. Today, we're diving into something that feels straight out of science fiction, but it's happening right now. We're talking about a massive shift in robotics, a move away from clunky, rigid code and towards, well, teaching robots how to dream.
For the longest time, robots have been kind of stuck. They've been chained to code, right? Super precise, math-heavy instructions where one little thing goes wrong and the whole system just breaks. But now, a whole new approach is flipping that script. We're entering an era where robots are flexible, they're intuitive, and they're not guided by code, but by seeing a goal.
And really, this is the core idea. The new visual foresight system operates on a principle that's so simple, but so powerful. Instead of painstakingly programming every single little coordinate and angle, you just show the robot what you want. You show it the finish line. You basically show it what to dream of.
To really get why this is such a huge deal, let's just quickly look at the old way of doing things. Traditionally, every single action a robot took had to be calculated perfectly by a programmer. Imagine if just one little block was an inch to the left of where it was supposed to be. The whole program could just fail. The robot would be completely lost, totally helpless.
Okay, so what's this new vision all about? It is literally about getting the robot an imagination. I'm not kidding. We're teaching it to dream, or if you want to get technical, to hallucinate what the finished task looks like before it even lifts a finger.
Yep, you heard that right. The system creates what they're calling a future selfie, a super realistic picture of the goal all done. And from there, the robot's job is simple. Just move your body around until what your camera sees matches that picture. That's it. So the big question is, how on earth does it actually pull this off?
Well, this incredible skill isn't magic, even though it kind of feels like it. It's actually the work of a dream team. 3 different AI parts, each with its own super important job, and they all work together perfectly.
All right, let's meet the team. You've got the strategist, that's the brain. Then there's the dreamer, the imagination. And finally, the actor, the muscle. And you need all 3 to turn a simple idea into a real-world action. Okay, first up, the strategist. This is powered by Gemini, and you can think of it like the mission controller. It's the part that gets the big picture. It understands physics, it knows the rules of a game, it even gets abstract ideas like what tidy actually means. It comes up with the overall plan.
Next in line is the Dreamer, which is a model called Nano Banana Pro. And this is, you guessed it, the system's imagination. It takes the plan from the strategist and turns it into a picture. It generates that future selfie. But here's the key. It's a selfie of what the world will look like after just the very next step is done.
And that brings us to the actor. This neural network is the muscle. It's pretty straightforward. It's constantly looking at 2 things, the real world through its camera and that dream image from the dreamer. Its only job? Figure out the physical moves to make those 2 pictures match up.
So there you have it, our dream team. The strategist, the dreamer, and the actor. Now let's see how this whole thing actually works in the real world. We're going to put the system through its paces with a few different tests. Okay, we're going to start with something pretty simple. The robot sees 3 blocks just scattered around on a mat. The goal is super clear. Line them up in a specific order. Blue, then red, then green.
So the strategist, that's Gemini, remember, looks at the scene and decides, okay, logical first step is to move the blue block where it needs to go. Then the Dreamer, Nano Banana Pro, kicks in. It creates a picture of the future where only the blue block is moved. See that? The red and green ones are still in the same spot. It's all about taking it one single step at a time.
And now it's the actor's turn. Its mission is simple. Move that real blue block until what its camera sees is a perfect match for the dream picture. And once that's done, the whole loop starts over. The strategist figures out what to do with the red block, the dreamer dreams it up, and the actor makes it a reality.
Okay, blocks are one thing, but what about something more chaotic? Things get way more interesting when the task is just tidy up this messy table. Now, the system has to figure out the difference between trash and, say, a pen. It has to know how to pick up weirdly shaped things like a crumpled piece of paper. And right away, you can start to see where this is going. From robot vacuums to maybe even helping people around the house.
But the real test, the ultimate challenge, is when the robot has to react on the fly to a human, someone who's totally unpredictable. So let's see how it does in a classic game of tic-tac-toe. Okay, so the human puts their X right in the middle. Instantly, the strategist analyzes the board and figures out the best counter move. Then, the dreamer creates that vision.
a picture of the board, but now with an O in the top left corner. And finally, the actor makes it happen. It picks up a token and places it, making the real world match that dream. And this whole cycle? It happens in a flash, after every single move the human makes.
So, we've gone from sorting blocks to playing a strategic game against a person. What's the big takeaway here? Well, this isn't just about making a smarter robot. This is a fundamental change in our entire relationship with them. And the implications for the future? They're massive. What we've really been watching is a complete, closed AI loop. You have cognition, the high-level understanding from Gemini. You have imagination, the visualization from Nano Banana Pro. And you have dexterity, the physical skill of the actor. The system connects thinking to seeing to doing, all seamlessly.
And if there's one thing to take away from all this, it's this. We're moving away from writing thousands and thousands of lines of fragile, complicated code. We are getting closer and closer to a future where programming a robot is as simple as just showing it a picture of what you want. It's like you're telling it a story with images. Look, this tech isn't just a small improvement. It's a key that unlocks a whole new frontier. So it leaves us with a really fascinating question. If a robot can achieve any goal that it can see, what should we ask it to dream of next? Thanks for joining this explainer.